Welcome you all. In this session, we are going to discuss the magnetic circuit calculation in electrical machine design. Magnetic circuit calculation. The path of magnetic flux is called as magnetic circuit. A magnetic circuit is analog to an electric circuit. In an electric circuit, Ohm's law expresses the relationship between current EMF and resistance, while in magnetic circuit a similar relation exists relating flux, MMF and reluctance. Phi is equal to AT cross S. Phi represents the flux, AT represents the MMF and S represents the reluctance of the circuit. Let us differentiate the electric and magnetic circuit. In electric circuit, current actually flows in the circuit. In magnetic circuit, flux does not flow, but we assume that it to be flow. In electric circuit, when current flows, energy is spent continuously. In magnetic circuit, energy is needed only to create the flux but not to maintain it. In electric circuit, resistance of electric circuit is independent of current strength, whereas in magnetic circuit, reluctance depends on the total flux. Magnetic leakage. For a magnetic circuit calculation, a term leakage coefficient is introduced in order to take into account the leakage flux. The value of this leakage coefficient is defined as leakage coefficient C, which is equal to useful flux plus leakage flux divided by useful flux. Types of leakage flux. The armature leakage flux affects most of the performance of rotating machine. Hence, different types of armature leakage fluxes are discussed in this session. The different types of armature leakage fluxes are: first one, slot leakage flux; second one, tooth top leakage flux; third one, zigzag leakage flux; fourth, overhang leakage flux; fifth one, harmonic or differential leakage flux; sixth, skew leakage flux; and the seventh one, peripheral leakage flux. These are the various types of leakage flux associated with rotating machine. First, let us discuss about the slot leakage flux. The flux that cross the slot from one tooth to the next and returning through iron are called as slot leakage flux. They link the conductors between them. Tooth top leakage flux. The flux flowing from top of one tooth to the top of another tooth, as shown in figure, is called as tooth top leakage flux. This flux is considered only in machine having large air gap length like DC machine and synchronous machines. Since in induction machine the air gap length is very small, the tooth top leakage flux is negligible. Zigzag leakage flux. The flux passing from one tooth to another in zigzag fashion across the air gap as shown in figure, we call them as zigzag leakage flux. The magnitude of flux depends on the length of air gap and relative positions of tips of rotor and stator. Overhang leakage flux. The end connections, the conductor which connects the two sides of coil, we call them as end connection or called as overhang. The flux produced by overhanging position of armature winding are called as overhanging leakage flux. It depends on arrangement of overhang and nearby metal parts. Harmonics or differential or belt leakage flux. The harmonic leakage flux is due to dissimilar MMF distribution in stator and rotor. Actually, the difference in harmonic contents of stator and rotor MMF produce a harmonic leakage flux. In squirrel cage induction rotor, current is exactly balanced by stator current, and so there is no harmonic leakage flux in squirrel cage machine. skew leakage flux, a twist provided in rotor of induction motor to eliminate harmonic torque and noise is called skewing. The skew reduces the mutual flux and thus create a difference between the total flux and mutual flux. This difference is accounted as skew leakage flux. Peripheral leakage flux. The flux flowing circumferentially round the air gap without linking with any of windings are called as peripheral leakage flux. Usually, this leakage flux is negligible in most of the machine. Thank you.